Alright YouTubers, here's some easy tips on extension cords. One of the goals here is you want to be able to quickly throw down your extension cord and be able to walk it out without it getting all kinked up, tied up, mixed up, jumbled up, whatever it is. So in order to do that, you need to learn how to wrap it correctly first. So in order to wrap it right, you need to learn to not wrap it wrong. And this is a classic example. Just put it around your arm and keep on twisting, nice and quick. But eventually you're going to end up with a jumbled mess when you try to walk it out. I'll give some tips on a couple different methods. The first one here is what I call the handoff or figure eight. Typically it makes sort of a figure eight, and you just put a little excess length on the end, and then just hand off directly. Hand off, hand off, hand off. Just a straight pull. And normally you'll get sort of a figure eight. This coil is still a little thick and young, so it's not doing it yet, but that's what you'll get. The other way, which I'll show here fully, is the over-under method. So what you want to do is start the same way you started the direct handoff figure eight, and you just want to loop, and on the next one you want to put a twist in, so it's sort of like the first one goes over, and the next one you fold it upon itself and it goes under. And you just repeat over, under, and this usually generates a pretty round method. Now when you get to the end, usually you just get the last loop, make it a little longer if you have to, and then just wrap it around and bring it through. You can wrap it around a couple times if your loops are really big, but most time, like on this one, you just bring it once through, and then you've got a nice hanging hook. Keep in mind you want to keep your ends from crossing up inside it, because that's usually another method that ties these things up into a jumbled knot. So let's go over some cable types, because that's kind of important. The first type is what I call the SJTW, and that is all over your Home Depot, Lowe's box stores. So the S is pretty universal. It's just for flexible wire extension cords, basically temporary grade. J, you can have the letter J or you cannot have the letter J. It doesn't really matter too much for what we're talking about with residential households with 120 volt in America. But the J is rated for junior grade or 300 volt maximum. If you don't have a J, it's hard grade or 600 volt maximum. It doesn't matter too much, it's just the insulation on the wires. Either one is acceptable, J or no J. The third letter that we typically encounter is either no letter or a T or an E. The T is the one we're talking about right now. It's the thermoplastic. It's this cheap PVC stuff that you see on the box stores. So generally I'll say avoid the T. It doesn't do well in cold weather. It gets old coil wrinkled up, not very flexible, and tends to wear out pretty quickly and fades in the light and whatnot. But you'll be buying new extension cords all the time if you buy T grade, so you might as well just upgrade a little bit, even though it's more expensive. The other types that we'll talk about are the E grade. I'll show you an example of that. That's a combination of these PVC or elastic thermo stuff and rubber, so it's a lot more flexible. It's a lot better wear resistant and a lot better cable to use. It's mid-priced between the two. And I'll show you that when that comes up. And of course the absence of a letter, no E, no T, is just the pure rubber grade. And that's probably the best one. It's a little heavier than everything else, but it's really flexible and stays flexible at temperature. And like I said, it's more expensive, but it's a better overall cable. The next typical letters are an O or an OO or no O, right? So no O means it's not retardant or resistant against oil and other chemicals and stuff like that. A single O, it means that the outer jacket is chemical resistant or oil resistant, and then an OO means that the outer jacket resistant and the wire insulation and the insides are oil resistant. Should you get a crack on the outer thing, you're not going to degrade if you're in that type of harsh environment with any type of oil, gas, whatever. And the last letter that's pretty typical is the W on the end, and that's for weather resistant. The absent of that means it's more of an indoor type cable. You will see STWs, SJTWs, or just SJTs, or something you might see on indoors. And SOOW or SJOOW is the premium grade. Now you can get SJOOW or SOOW in the by the foot, sort of a big Lectriever, I call it, the big spinning drum where you got to get a guy to assist you, and you know, sometimes they don't have all those in stock, but you can get them. I order them on Home Depot, and you know, like I said, they're a little pricey, they're heavier, and you're gonna have to buy some connectors and wire it all up yourself. But like I said, that's a long-lasting cord, and it's nice and flexible, and it's easy to do this wrapping and stuff that you have. So back here, I have an example of one that's been used a little bit. This is your SJTW box store, and you can see it's got itself all coiled up and kind of a crappy looking. A lot of times they fade on you or split on you. The ends are usually this cheap rubber. The next one that I bought here off of Amazon, you might be able to find some sizes, but I couldn't find what I was looking for in like maybe an Ace Hardware or maybe an off shelf. But this one happens to be an SJEOOW, so it's a pretty quality cable. This one was about $45 for 50 feet on Amazon, and it's still got the cheap type of connectors down here, or a little bit maybe more a little stout. Of course they light up in this particular one, but this is what you want to kind of aim towards. This is what happens to be 12 gauge. We'll talk about sizes and lengths in a little bit. And the last couple are an SJOOW. This happens to be a 50 footer. I bought this at Home Depot, and the connectors, I put some high quality connectors, so they're about $15 a pop, connectors on top of them. So yeah, it's a pretty expensive cable. I think it's $1 a foot. So you got $50 plus another $30 in connectors, but this is my go-to high quality cable. You see it's wearing well and doing well. I just replaced the connectors on it recently because I beat up the other ones pretty good, but it's in good shape. The other one I've got over here is a remnant that I had bought at Home Depot. It was 13 feet of 10 gauge, and you can see just how big the 10 gauge is. A big price jump between 12 gauge and 10 gauge. And I put these $5 connectors. I kind of like them. They're rubberized or whatever, they're weather sealant. Like I said, I just kind of use those for very short runs to go to my power equipment, but it's a nice alternate cable. Okay, let's switch subjects and talk about wire sizing and lengths. Depends on what you want to power, but a lot of times you are powering some kind of motor. Electric motor, whether, you know, we're talking about circular saws, table saws, refrigerators, everything's got a motor, right? If you're just going to light up a light bulb or use it without a motored item, then, you know, it doesn't take a lot of watts, then it's something that you typically wouldn't need these heavy duty cables for. You could get away with some light duty cables like light bulbs and stuff. I mean, you got to watch what kind of amperage you're drawing, because amperage is the enemy to your wires. The more amps, the more it heats up. There's always resistance in your wires. So the smaller your wire, and the longer your wire run, the more resistance or voltage drop. And that's the big thing we want to look at. So a general rule of thumb, and it's sort of in a lot of local codes for your electrical wiring, the last trunk, which is what you go to your wall, you know, your wall socket where you plug in at, is typically no more than a 3% voltage drop. Most equipment will handle that without a problem, but when you start getting, you know, 8-10%, you know, voltage drop, definitely your motors can suffer, and they'll overheat, and they'll run slow, and they'll bind down and stuff like that, you know, under load. And eventually, you know, if you really get this wrong, you'll wear out your motor, overheat it over time. Usually it doesn't catastrophically fail right away, but you know, that's what motors want to do typically. And so you'll wear out your equipment. You think you're harder on your equipment, but you just had the wrong size cable. So I usually recommend 12 AWG, but in this calculator net dot here, I've got copper wire, 12 gauge, 120 volt, single phase, single set of connectors, 50 feet, and I'm going to put 15 amps for a 15 amp circuit. And when I hit the calculate button, I'll get a voltage drop of 2.38 or 1.99%. That's what you're really looking for. No more than 3. The lower is better, but this is a good way to look at what you're doing. Now, you're not always drawing 15 amps, but it's a good rule of thumb for 15 amps to go with 12 gauge and no more than 50 feet, or at least know what you're powering. So using the voltage drop calculator, here are some typical lengths where you hit that 3%. For 12 gauge, it'll be 75 feet. Of course, 12 gauge wire is rated for 25 amps in general. So good item to use on most circuits. 14 gauge runs out at 3% at 47 feet. So it's not a bad candidate for a 50-foot wire, but the price between 14 and 12 is not tremendous. So usually it's worth upgrading to 12. Also remember, 14 gauge itself is rated for 18 amps. So should you ever find yourself on a 20 amp circuit in your house, which you might have, just be aware that there's a little bit of not circuit protection because your wire will be a circuit protector should you draw, let's just say, 19 amps, right, for some reason. You won't trip the breaker and you'll burn out the cord eventually. 16 gauge is even more prevalent. That runs out at 3% at 30 feet. So you can use it for a 25 footer and get no more than 3% drop. But keep in mind, 16 gauge, same thing, is rated for 13 amps. So again, even on a 15 amp circuit, you might have a small opportunity to be running 14, 15 amps and not trip the breaker, and your wire again is the breaker. So not a good deal. So always use at least 14 gauge on a 15 amp circuit, and I always recommend 12 gauge, just go with it. 18 gauge is pretty useless. Well, I mean, it's useful for small loads, 5 amps, maybe 8 amps or something, but yeah, the 3% dropout for 15 amps is at 18 feet, so don't bother with it, don't plug it. If you're going to be drawing heavy loads, you're going to power a light bulb or something low amperage, but again, I always say keep a 50 foot or under for your high amperage items, and 12 gauge. So I want to go over the prices of some box store SJTW, pretty typical. I know I don't totally recommend going with them, but just to give some examples of cost and price of upgrading your wires. First column, I got the wire size, so 16.3 is 3 wire 16 gauge. Then I got 14 gauge, 12 gauge, and 10 gauge as I go down the rows. Of course, I gave you the ratings. Those are 13, 18, 25, and 30. We didn't talk a lot about 10 gauge. But the cost is in the third column, so you can get it starting at about $13, and a typical average is more about $20. They'll try to sell you on some upgrading, right, and colors and stuff like that, but 13 to 20 for 16 gauge. 14 gauge will be 22, starts at about 22 for the cheapest one. 25, these are all Home Depot prices, just for reference. The 12 gauge goes 25 to 35, so the average jumps up a little bit, but the starting price isn't that much more. So it's not that much more as we see you got a big quality jump going to 12 gauge. But if you ever go to 10 gauge, notice the price down there. It's 66 and 70. These are all for 50 footers. You'll see like a $150 or $130 one and a 100 foot, because sometimes they recommend 10 gauge going out to 100 foot. But you can see that's a nice price sensitive point for that 12 gauge. So if you can get it, if you happen to have to buy SJTW, but keep in mind that once you get out to like the 10 gauge and the 100 footers, it gets pretty price competitive to buy it by the foot. For the SOOW, for example, right? Nice rubber premium grade extension wire. And the weight, I just put as a reference out there. 3, 5, 7, and 11. You can see a big jump in weight for that last gauge. Keeping in mind that an SOOW cable was going to be about 1.5 times the weight. It's just a more ruggedized cable, so that 7 will be 11, for example, on the 12 gauge 50 footer and upwards. So yeah, it's a lot heavier cable, but this is a good reference here. So I'd like to wrap up my video with 10 quick tips here. So tip number one, get the kinks and twists out. When you get a new cable, maybe you lay it out in the sun for a little bit, just get it out so it's nice and get the twist out of it, right? So it'll coil up nice for you and you won't have to struggle with it. Number two is learn to coil to keep the twist out. So I didn't show you the half twist. You can roll it and do a half twist, but I showed you over under, I showed you the figure eight and how to take the last wrap and hang it. That's usually the best way to keep a cable nice and clean, at least an extension cord. Tip number three, fully unwrap before use. So a lot of people like to put them in a bucket or keep it in a pile. Now, the enemy is heat, right? So the more you bundle wires together, the more they don't want to dissipate heat. There's also some little bit of a magnetic field if you have a long enough wire and you wrap it. You know that from old physics. Of course, don't put them under rugs and stuff like that, especially for long term. That's just not going to dissipate your heat, and that's usually how house fires start. Not that you would put a rug outdoors with these heavy-duty cables, but just FYI. Tip number four, avoid the T-type if you can. Go for SOOW, SJOOW. The E's are a good alternative. That was like $42 versus, $35. You got to pay another $7, but you get a much nicer flexible cable, especially in the cold. SJTW is your box store type. Tip 5, 15 amp service is 14 AWG minimum, is usually what you see in the residential, up to about 25 feet. Then they go with 12 gauge. So if you're going to put an extension cord and you're going to draw some amperage to be safe, just use 12 gauge, right? Or better if you can, or keep that length down. Tip number 6, there's the voltage drop calculator that I had shown earlier. Just 12 gauge again will get you out to 75 feet, so 50 feet is pretty good. Tip number 7, 50 feet or less, 12 gauge. I recommend having one of those. Tip number 8, I didn't show the tools for amp measurements, but you can use various instruments, kilowatts, or one of those amp meters, right? Some kind of amp meter, appliance load, just to see what kind of amps you're drawing. So you can have an idea what your tool is pulling, both when you fire it up and under load. Give you an idea. So if you're really drawing a lot of amperage, you'll definitely want to check your voltage drop and see if you got an appropriate cable. That's tip number 9. We talked a little bit about you're choking the motor when you have the too much voltage drop, or you just have too long of a cable or too small of a cable. You'll end up choking the motor and drawing more current and or slowing it down, which means less cooling for the motor. You wear them out eventually. Don't pay attention to the nameplates on the motors. Those motors typically run less, but they'll draw a lot more than their rating when they're under load or when they're starting. Ignore the whole 15 amp thing. Your breaker won't trip on it. And tip number 10 is build your own cables, at least one or two, and you'll enjoy them. They'll wrap a lot better for you, and they'll last a lot longer, and you get a little bit of pride of ownership there. Loan out your crappy cables. Of course, I didn't put a tip down there. When you loan out your equipment, especially if it's nice high amperage equipment, don't rely on the goofball to have a nice cable. Go ahead and loan a nice cable with it. If you ever rent equipment, especially power equipment, a lot of times they'll give you a cable that you'll have to use because they don't want you using your cheap crap ass SJTW $15 Home Depot cable. All right, so those are my tips. Hope you enjoyed it. Have a good one.